Hello everyone. In the previous lecture, we aborted the demonstration for DAG generation to get completed. In this lecture, we'll proceed further. It can be seen on the screen that DAG generation is completed 100% and the mining process has begun. You can see blocks are getting mined as it shows mined potential block 1, mined potential block 2, and so on. The hammer symbol indicates the new block. If we check the balance of our Coinbase accounts or Etherbase accounts in the same way we did earlier using the command web.eth.getBalance web3.eth.accounts (0) end brackets, it shows the Way count and not the Ether. To check the balance in Ether, we need to convert Way into Ether using the command web3.fromWay web3.eth.getBalance web3.eth.accounts (0) end brackets, Ether end brackets. The return value is 253.59375. This means that we have 253.59375 Ether in our balance, which was 0 earlier. On refreshing or rechecking, it keeps on increasing. The reason it increases is mining. The miner is mining new block. Node 1 is mining new blocks every few seconds. The frequency, difficulty, and other aspects depends on the setting created using the Genesis block. Now, let's stop the mining using the command miner.stop brackets. If you check the log interface, you'll observe the mining has stopped from block 77. Till this point, you've learned the way to stop and start mining and to check the balance. Next, the same thing can be done for node 2. Like, if we try to start mining in node 2 using the command miner.start brackets, it asks for Coinbase account or Etherbase account. We can set the Etherbase account using the commands miner.setEtherbase Coinbase address end brackets. You need to enter the Coinbase address in functions parameter. Remember, we are actually going to mine the Ether in node 1 account, rather than mining the Ether in 2 different accounts. We'll do it in a single account. The Coinbase address being entered belongs to node 1. Now, if we start the mining using the command miner.start brackets, the mining procedure actually begins. It will generate DAG again. Note that this mining is independent in its own blockchain, because both the peers are disconnected to each other. So we're going to stop the mining. But this won't affect DAG generation. It will get completed automatically. We will start mining after connecting node 1 and node 2. Note that mining will begin from block 77 of node 1 and not from the initial block. To connect both the nodes, the inode address is required. To get the same, run the command admin.nodeinfo.inode on node 2 command line. It returns the node 2 inode address. Let's keep it somewhere handy. Remember, this section should be replaced with the private IP address. So copy the private IP address of node 2 and replace it. Similarly, extract the node address and private IP address of node 1. Till this point, we have found a node address of both the nodes, node 1 and node 2. So, to add node 2 to node 1, execute the command admin.addPeer node 2 and node address end brackets at node 1 command line. It returns true, indicating node 2 has been added as a peer. In the same way, node 1 can be added to node 2 using the command admin.addPeer node 1 and node address end brackets at node 2 command line. Though this is optional, you can do either of two. You can check the peer count by executing the command net at node 1 command line. This displays 1 as peer count. To check if the peers are connected properly, Execute the commands admin.peers. Check the local address and remote address to be same as the public and private address. In this case, both are the same. Therefore, peers are connected properly. The DAG generation for node 2 is about to finish. So let's start mining from node 2 so that it could continue from node 1. Execute the commands miner.starts brackets at node 2 command line. DAG generation is about to complete. Then node 2 will start mining. Now, new blocks are added from node 2, so node 1 must get the updated blocks. Just check at node 1 log interface. New blocks are mined by node 2 and are important to node 1. Hence, the nodes are connected perfectly and are working well. Now, if you check the balance using the commands web3.fromWay bracket web3.eth.getBalance bracket web3.eth.accounts bracket 0 end brackets ether, the ether must increase. Here, it is not increasing yet. No worries. It is not necessary for the nodes to be connected all the time. If we check again, now the ethers have increased. This is how the nodes are connected. Note that we can have numerous secondary nodes, but they need to be connected to primary nodes so they can mine together. Or we can connect one peer to another peer and from peer-to-peer network where any miner can perform mining and the mine block be available to all nodes all the time, just like we did. A block was mined by one node and imported to another node. If a large network is formed, miners will update each other about the blocks and balance will be updated and increased as long as mining continues. So, this was all. Hope you had a clear understanding on connecting the peers. Thank you.